Hello, and welcome to this presentation, Understanding DARC. In this short presentation, we'll explain how the data radio channel, or DARC, can be used to carry digital information within standard FM stereo broadcasts. Let's start by reviewing standard FM stereo signals. These consist of a main mono channel occupying the frequency range of 30 Hz to 15 kHz. A pilot tone at 19 kHz is used to indicate that stereo information is present, and this stereo information is encoded into a 30 kHz wide subchannel centered around a suppressed subcarrier at 38 kHz. Note that the subcarrier has a frequency that's twice the frequency of the 19 kHz pilot tone. Together, these components occupy approximately 53 kHz of spectrum. Note that in most parts of the world, the spacing of FM broadcast channels is 100 kHz, and in some places, such as North America and Australia, the spacing is 200 kHz. This means that there's often a significant amount of unused spectrum per FM broadcast channel. The spectrum above the FM stereo signal can therefore be used to send data or digital information along with the analog audio. One method of doing this is the radio data system, or RDS, which is very commonly used to send textual information in the form of station and program identifiers. It can also be used to send traffic and other alert information. RDS is implemented in the form of a 5 kHz wide subcarrier centered around 57 kHz. An additional, although much less common way of sending digital data within FM broadcast signals is the data radio channel, or DARC. This can be used to send medium bitrate digital data, primarily for use in public information and transportation applications. DARC is implemented as an additional 34 kHz wide subcarrier centered around 76 kHz. It's worth pointing out that the RDS subcarrier frequency and the center of the DARC subcarrier are also multiples of the 19 kHz pilot tone. Over the next few slides, we'll take a closer look at DARC and how DARC is tested. DARC has been primarily used for distributing data to public transportation signs. Munich, Germany, and Helsinki, Sweden, are two examples of where DARC has been deployed for this purpose. Because DARC is transmitted within, or piggybacked onto, standard FM broadcast signals, it has roughly the same receive or coverage area as the associated stereo audio signal. DARC can, however, also be used for any type of general data transfer. It was originally intended for distributing traffic information, and there have also been proposals to use DARC for transmitting differential GPS data. But although the standard was first published in 1997, DARC has still not been widely deployed outside of the special application mentioned above. The most recent version of the DARC standard, ETSI-EN 300-751, was published in 2003. DARC uses a special form of minimum shift keying called LMSK, where the L stands for level controlled. This form of modulation is similar to traditional MSK, but the amplitude or level is also adjusted between two values. This is done in order to improve resistance to multipath and bit errors, which is particularly important in the urban environments where DARC is typically deployed. DARC uses a standard bit rate of 16 kilobits per second, and the transmitted data is organized into frames consisting of 78,336 bits. These bits are split into 272 rows, or blocks, and each block contains 288 bits. Blocks each start with a 16-bit block identification code, and error correction information is also incorporated into the data. DARC is tested using vector signal generators to create an FM broadcast signal with an inserted DARC subcarrier. This RF signal is then input into the device under test, or receiver, either via a conducted connection or over the air by means of an appropriate antenna. Typically, testing involves transmitting user-defined block identification codes and data, and then monitoring the device under test. The generator may also add noise and/or interference to the signal in order to determine if the system can function properly in the presence of impairments. Let's end with a brief summary. There are two ways in which digital data can be transmitted within standard FM stereo broadcast signals. The first of these is the well-known Radio Data Service, or RDS, which is very commonly used to display station and program information on radio receivers. The second is DARC, or the Data Radio Channel. Although DARC is a generic data transfer service, it's primarily used for sending transportation-related information to signs, etc. DARC is defined in ETSI standard EN 300-751 and transmits data at 16 kilobits per second using a special level-controlled variant of minimum shift keying. This data is sent in the form of blocks, each with a block identification code. DARC receivers can be tested by using a vector signal generator to create FM stereo signals which contain user-defined DARC data. And in some cases, these generators can also introduce impairments into the signal for testing robustness or error detection and correction. This concludes our presentation, Understanding DARC. If you're interested in learning more about broadcast standards or how broadcast standards are tested, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.